Hi there. In this video, I'll be talking about a prototype I made a couple years back with the assistance of a friend. The idea of it was an electric tooth flosser, similar to an electric toothbrush. And I spent a few months working on it and came up with a functional prototype, which is this model here. So that sounds quite intense, but it's not the finished version. And the idea was to have a piece of floss across this part here. So this would be a removable, disposable piece, which would have tooth floss in it. And the base is just kind of like a rechargeable permanent unit that creates some vibration. So you put the dental floss head on top, turn it on, and you would put it in between your teeth, sort of like this. So in this video, I'll be talking about a few aspects of this project. The first of which will just be the concept and the idea, and how I came up with that with the assistance of my colleague. So check down below in the description and I'll have some timestamps of these points you can jump to, depending on what's relevant for you. The next point will be the prototyping, the design and the engineering, how I actually designed this and modeled it on the computer and physically made it. So just to give you a quick view of the inside, there's some electronics and mechanics involved. And also the unit is rechargeable, so I'll just quickly move the camera to show you. This is sort of the recharging docking base. So you can see as I put it down, an orange light comes on, which means it's charging. And when it's fully charged, that would turn to green. Then I'll get on to the testing and the user feedback. So I did get a few people to try this out, and the feedback was actually quite good. So I'll speak briefly about that. The next step was determining how we would get a small batch manufactured, say 20 to 50, just to do a first sort of beta testing of these units. And I'll discuss that. And then the final step is the large-scale manufacturing and the business evaluation. And in that point, I'll talk about why I didn't pursue this idea or this project further. But regardless, I actually learned quite a lot from this, about sort of business and trying to set up a small company if I were to do so. And more importantly, a lot about engineering and design engineering. So I'm a mechanical engineer now, and this project was quite valuable to me, and I'll discuss that more as we go throughout the video. All right, so looking at the initial concept there and the idea of this project or this product, it actually came from a friend of a friend who had done some kind of project or task at university on coming up with product for an industrial design project. I don't want to talk too much about her work, but she put together like quite a good range of work on like a concept of such a thing, and did a rough model, like an aesthetic model and some drawings. So when she approached me, she actually had this model of it, which wasn't a functional unit, but just sort of demonstrated the concept and the form of the idea. Her initial idea was to have sort of a roll of tooth floss in the center here, which would be replaceable. And that would feed up in such a way that it would sort of loop around and pass through this top here. The idea was to have a motor in here that would rotate this round, and the floss would run around, and then you would put that between your teeth. And the power button would just sort of be on the side, and you would have a light somewhere here, a little LED to just let you see what you're doing inside your mouth a bit easier. The problem I had with this idea was that I didn't think it was very hygienic, because obviously you could have like a lot of gross stuff and dirty stuff in between your teeth. So as the floss would pull that off, it would pull it back inside the device. At the time she approached me, I was actually working as a research engineer in a medical device company that specialized in infection prevention, and they made devices that would sterilize and disinfect medical equipment. I was just thinking, if you had something that was, sort of pulling bacteria inside these small paths, these small channels, it would create like a lot of like biofilm and just get dirty over time. And it wouldn't be something that you would want to continuously put inside your mouth. I had to think about it, and initially at first, to be honest, I didn't think it was really a good idea. I wasn't that keen to work on the project. But I thought about it a few months later. I thought, why not? May as well give it a go. I had some spare time on my hands. I came up with the idea of a replaceable head and actually looked at some electric tooth flossers. And electric tooth flossers tend to have a circular head at the top. I used to think it just sort of rotated around continuously, but it actually just sort of swivels back and forth. So I opened the old one I had up, and it had a mechanism inside that sort of caused some knocking back and forth, which translates to vibration roughly. The idea was that I would have this shaft which would swivel back and forth, rotate slightly on the spot, and then you would put this head on, which would also rotate, and the end effect was just some vibration. This is a bit intense, but it could have easily been toned down for something more subtle and smooth. The idea in my mind was that that vibration would sort of just help loosen up any kind of plaque or stuff between your teeth and would help insert the floss between your teeth. And the general shape of the thing would be nice to handle and manipulate to put inside your mouth, and the light would sort of help you see things a bit clearer. Turned out that Oral-B actually made a device similar to this in the past, which was called the Oral-B Hummingbird. This device was discontinued, so through all of my research I couldn't actually find the exact reason of why it was discontinued, but it seemed like a fairly nifty device. It again had the replaceable floss head, so I hadn't thought of anything new there. Found some forums where some people were asking if they could still get this device and they'd be a fan if it came back. So yeah, I wasn't clear why this was discontinued. The first thought that came to my mind was that it wasn't selling well. There wasn't necessarily a market for it. People didn't want it, but there were still quite a few people on this forum I found that were asking for it to come back. And I think possibly even still to this day, you can buy replacement heads for the Oral-B Hummingbird on eBay. The price is ridiculously expensive now. But I thought, it's one of these things you don't really know if this kind of product would sell until it was sort of on the market, and a lot of it would depend on marketing as well. So I thought, why not give it a shot? I really hadn't invested much money or time into it so far, so was quite optimistic at that point. All right, jumping straight into the mechanical design. So it won't be possible for me to cover every detail in this video, but if there are any questions you have, feel free to comment below, and I'll try to get back to you with some useful information. So yeah, when I first started, the first fundamental step was really just thinking about how I wanted the mechanism to work. As I said earlier, the sort of form was given to me by a friend of a friend, and I decided that I would have a removable head that would vibrate roughly like this, just back and forth, minimal vibration. And one thing that you couldn't see on the prototype I showed earlier was the actual floss embedded in the replaceable head. So that was one thing that was difficult to prototype. I did actually prototype it, but I don't have that model anymore, but I'll talk about that in a little bit. So before I get to this final model, which actually has all the internal electronics and whatnot visible in there, I'll just go back a few steps. So First of all, I started with modeling some different shapes and forms. So I think this unit on the left was one of the first models I did, which had the sort of rough idea of how I wanted the mechanism to work. But this doesn't look as nice as the final units. And just with general design and engineering, you go through a range of iterations, and each unit gets progressively better until you get to a point where you're satisfied with it. So from this early stage on the left, I went to a more sort of streamlined unit in the middle, but it was still quite round and big and just looked a bit sort of like inflated. And then I ended up getting to this unit on the right, which is more representative of what I wanted to go for. Because this thing needed to be quite small, I needed to work with small components. So to determine the actual size of it, or the ideal size it could be, I had to first figure out what components I was going to work with. So I knew I needed a little motor for the vibration mechanism. And basically I was sort of copying the vibration mechanism that I'd found in an electric toothbrush. And I just encourage people in general to, if you're a tinkerer or an engineer or designer, to open up mechanisms out there and have a look what's inside. So an electric toothbrush, like shown here, actually has sort of a motor inside creating some vibration, and the circular head up here doesn't continuously rotate around, but just swivels back and forth. And I used a similar mechanism in the electric tooth flosser. So to find the motor, I was just looking for micro motors, the smallest motors I could get, and I found this company, Pololu, that makes a range of small motors. So I decided what voltage and gear ratio I needed and ordered a few of these and then modeled them up so I'd have an idea of their size. I also found some other components. So some important ones were a small lithium-ion battery. So I did some rough calculations of how long I would need this thing to last, at least sort of like 10-15 minutes, ideally longer, so it doesn't have to be recharged in between each use. But I found that 350 milliamp hours was suitable. So from there, I ordered one of these and got the size and dimensions. I also had to get a little power board, which is essentially like a power regulator, a power supply. So you plug the battery into this and then plug the motor into this, essentially. I also found some little wireless charging units. So these things were quite cool. Essentially, they're two copper coils, and through inductive recharging, you can basically place one of these coils on the other. So one of them will be connected to a power supply. The other will be connected to a little recharging board, which then plugs into your power board. And they can be separated by, I think, up to 5 millimeters, half a centimeter. And yeah, so one of these was sitting inside the unit and the other was sitting inside a little recharging base or a docking station. And some other basic components were just like some power switches, some cables with connectors, some little LEDs. As I mentioned earlier, there was a little LED in the device. So once I'd ordered all these things, I did a model of them in Solidworks, and from there essentially started making the size ideal. So again, this is an iterative process. Sort of this motor is attached to various little components. I'll quickly try to explain it here, but this shaft on this piece is offset from the center. So as it rotates around, it's not staying in the center. If you can see that there, hopefully. And what that does is this little cam piece that's connected to it sort of swivels back and forth. If you can see that. And then this little steel pin is connected to this cam piece, which is connected to another arm up here, which is then finally connected to a shaft that the floss head sits on. So the final result is we get this vibration back and forth of the floss head, which comes directly from the rotation of this little micro motor here. So these pieces here are just some little ball bearings that contain the unit. So the ball bearings are quite necessary to help keep the unit stable and secure, and also minimize friction. So we don't want the shaft just sitting on a piece of plastic that it's sliding against. We actually want it rotating in a ball bearing. And we have a couple ball bearings placed up here as well. This design is by no means optimized. It was just a prototype, so it's not ready for complete mass manufacture. And I put a couple O-rings in there to try help keep it watertight, but that would have required a bit more development to get it to a robust level. The LED was positioned here. I'll just change the transparency of that. So yeah, that was sitting in there, and its wires were running along down to the main circuit board. And I'll also demonstrate this on the real model shortly. And if I change the transparency of this piece, we can see that the lithium-ion battery is sitting at the base of the lower half of the unit. So, sorry, also these things are split into two halves. So if I open this component, this is the bottom half of the piece. So we can see the little mounting features for the ball bearings. These are sort of just some cylinders. I call them alignment guides. And if I show you the top piece, it will make a bit more sense. So the top piece had the male equivalents, so they would sort of lock into place. I think my plan for securing the prototype was to just put a few drops of super glue on the male alignment guides, and then they would bond with the other piece. These pieces here, they were actually little mounts for the micro motor. I was sort of trying to design them so they would be kind of like a snap fit. If you can see these little lips on here, when you push the motor down into place, these arms would extend outwards and the motor would snap in. But yeah, that by no means is the only way to do it. I think also this was a little feature to place a screw in to more firmly secure the motor in place. So back to the full assembly. Now this is sort of like where it ended up. It took me a little while to get to this position. So essentially I would have like my rough model, and then I would manipulate my components and place them in different sections and see if everything would fit. Do interference checking in Solidworks. I might demonstrate that in some other videos later on. And yeah, it was just like an iterative process. So maybe one day I would make sure that the motor would fit in place. And to do that, I might have to extend the length of the body and whatnot and manipulate the width and the form. Till eventually I got to a point where I had everything in there. So this was just a little power on and off switch. This down here is the coil for the wireless inductive recharging. And this was the little circuit board that came connected to the coil. And besides that, there was this other piece on the bottom, like a third part of the body. That probably in hindsight wasn't necessary, but it was just one way I went about designing it. And finally, I had this base piece. So the base piece also had the other recharging coil in there, which was wired to a power supply. So essentially, when you place these things next to each other, the thing would automatically recharge. So compared to the Oral-B Hummingbird, the other flosser that was on the market, that was just powered by a single AAA battery. I did actually order one of those Oral-B Hummingbird units off eBay. Some people sell some old stock, and you can see that the price is quite crazy now, $150 US. And upon sort of opening this thing up, it was quite good, but one negative thing I found was that because it was just powered by a single battery that had this screw cap on and off, I think it wasn't completely protected from the elements or protected from water per se. And I found that the contacts on the battery weren't so good. There was a bit of rust and corrosion. So that possibly could have been an issue with this unit, and perhaps they didn't want to redesign it, so it was more cost effective for them to discontinue the model. So yeah, a couple more important points. The removable floss head would be a disposable thing, so they would just clip on and off as discussed before, and the floss would be embedded in the plastic. So the idea was that when these pieces were injection molded, the plastic would be held taut in the mold and it would sort of flow over it. I think that's like commonly done in disposable floss picks. To prototype that, it was kind of hard. I think what I did was with one of my 3D prints, I drilled a tiny 0.6 millimeter hole and fed the floss through with a knot on one end, and then on the other end tie together another knot, but it didn't really end up being super tight. These are blue pieces. They were actually some little silicone grips. So if I just open one of them, so you can see it was sort of like a shell shape, and this was made out of like a rubbery silicone material to give the unit a nice feel. And if I open up the top shell, for example, on the exterior surface, we can see this sort of big recess, this big indentation where the seal would sit. So to actually make that, I made a mold, which was the inverse of the silicone grip. And then I bought some silicone mixture with some blue dye and mixed it together and injected it into the mold. So that probably deserves its own video of how to do that. So subscribe to the channel, and in the future I'll make a video of how to make silicone molds. So if that was going into mass production, that would just be overmolded in the plastic injection molding process, which is a technique of sort of combining a softer material onto a harder plastic. And I produced some renders of this unit. This is an exploded view of the model and all the internal components. Some other images. I think this was another model where I was thinking of having the LED on top, but it turned out that it was more useful having it on the underside of the model. Just some general pictures. So also I did plan on having the power button to turn the thing on and off underneath the silicone grip or TPE grip, but that was more difficult to prototype. So for the initial prototype, just having a switch on the side, as shown here, was easier, and it didn't really detract from the overall evaluation of the concept. So I actually also had this document I put together, which was just kind of a design review for potentially getting this thing manufactured. I'll share that look in the description below if anybody's interested and wants to have a read of this. The plan was to get the pieces in plastic injection molded with a overmold of the grip. Yeah, this is just a brief document, so feel free to give it a read if you're interested. So now talking about how I actually physically made a prototype of this, I decided to go with 3D printing. It's a quite useful way of rapidly prototyping small objects. So I don't own a 3D printer myself. I don't really have the space for it in my home. But I was aware of this website called 3D Hubs, which essentially, back when I used it several years ago, it basically consisted of local people in your city or your area that had various equipment like 3D printing machines or CNC machines, and you would upload your designs and get quotes from various people, and yeah, then choose the services you want. So for this piece, I wanted it to be pretty high quality, so I decided to go with SLA or resin printing, which is also watertight and 100% solid. So yeah, basically I uploaded my files, selected resin, SLA print, and it would give me a quote. So to get things prototyped is quite expensive. This actually looks more expensive than what it should be just for a single part, but yeah, I haven't really played around with the options here. For example, if you change the resolution, it should be a little bit cheaper. But nevertheless, prototyping is always going to be more expensive per unit than final manufacturing. So all these pieces were 3D printed using SLA resin technology. So I'll just take these apart in half there. So also, as I mentioned, the silicone grips. So these were essentially, it was a two-part mold that came together, and I injected the silicone inside, let it cure, and then took this out. I'll definitely make a video about doing this in the future and how to make it decent quality. And the plan was to just sort of glue them in place in their respective parts. So here we can see the little micro motor that's connected to sort of the knocking mechanism, or the little camshaft, which drives this little arm connected to this steel pin on the shaft. Here we have the circuit power regulation board connected to the inductive recharging coil. Underneath the board we have the lithium battery, which is not really visible here. I'll try. You can sort of just see the yellow tape of it there. And the micro power switch, and then little power leads running up to the LED. So these power leads here, and the LED is just positioned in there. So if I turn this thing on, you can't really see it on the camera, but this shaft is vibrating. If I hold this metal pen next to it, you can hear it. Just turn that off. And then when the head is on place, causes vibration of this head. So also, as I mentioned, this would be permanently bonded together, but because this is a demonstration unit, I didn't actually do that. Clamp it back together. So I have my little DC power supply here, and some power leads connected to the other end of the recharging unit. So as I power on the power supply, you can see that an orange light comes on inside, which just means that the thing's recharging. If I lift it off out of range, it loses contact. And when this is redone charging, a green light would come on. So this is indicative of what the final unit would be like, but obviously it'd be more robust and packaged together in a sealed unit. So I also had to do some basic machining along the way. You're not going to be able to see this on the camera, but I drilled a very small hole in there using a drill press, and it was actually a drill bit used to clear out 3D printer heads, FDM heads, or extrusion nozzles. Moving on to the testing of this, or the user feedback, people did actually, so I think I had about 5 or 10 close friends and family try it out, and they thought it was pretty good. Like, it was easy to sort of get inside the mouth. The light helped illuminate the teeth, and you could see what was going on. The vibration sort of helped the floss glide in between the teeth. And overall, the experience was positive, also because it's like a little cool electronic device that motivates people to floss more and practice more dental hygiene practices. One negative thing I found, and this was actually testing it on myself, was that if you pushed it in between teeth and the floss sort of got wedged in place, when you pulled it out, the head would tend to come off, and then this would be stuck in between your teeth. So that definitely needed to be fixed. So I began looking at a different style of design, one where the floss head would sort of slide in sideways, and this metal shaft would have another solid metal piece bonded to it. It would sort of be a snap fit mechanism in that you'd sort of have this small channel that it would pass through to get on there. And then once this was on there, obviously any sort of like upwards or downwards pulling force, any force along the axes of the shaft, wouldn't pull this thing off, so it wouldn't get wedged between your teeth. And to get it off, you would just sort of move this thing sideways, maybe use your thumb to pop it off. And a lot of this stuff, sort of like snap fit assemblies, you need to kind of experiment with the final material you're using and the manufacturing process. So this was just a concept, and I sort of stopped working on the model around here, so I didn't really develop this further. I think now I'll actually talk about why I did stop working on this and why I didn't try take it any further. The idea was to sort of put this thing on Kickstarter as sort of like a new novel kind of product. It was similar to the Oral-B Hummingbird in the past. As I mentioned earlier, it seemed like there was still sort of a desire for the Oral-B hummingbird. So, I felt like I was at a level where I had a working prototype. Could have produced maybe 10 of these, maybe 20 by myself, but I could have got some other people to help me out to make some more. And then I'm sure you know how Kickstarter works, but have a goal, and once we raise that goal, look to going into final manufacture with this thing. To manufacture this thing, the plan was to, go to China or approach some Chinese companies, talk with them about what they would think would be necessary design changes. The plan was to just use injection molding, kind of standard materials like ABS and whatnot. So I started looking into medical device classification and regulation. And medical devices come in a range of classes. So class 1 being the lowest risk, things like tongue depressors, which are just basically like wooden popsicle sticks used to like lower a tongue, all the way up to active implantable medical devices. So things like defibrillators, things that monitor your heart, or brain implants, very high risk things. So obviously our higher classes have more scrutinized controls, and you need to meet a lot of requirements before those things can even be listed as products. Lower classes have lower controls, but obviously there are still some things that need to be reached, or there are still standards that need to be met. So because this kind of electric tooth flosser wasn't really on the market, the Oral-B hummingbird was not on the market anymore, so I couldn't find any FDA classification on it. But I did find that an electric toothbrush, as seen here, is classified as a device class 1. And it's, if we see here, the recognized consensus standard, saying powered toothbrushes, general requirements, and test methods. So essentially what that means is for this thing to go on the market, you need to meet these FDA standards. So what does that mean? So found some information in the past, and I wrote that, like dental floss, this device would be considered a class 1 medical device, which would be subject to general controls. General controls include provisions that relate to adulteration, misbranding, device registration and listing, pre-market notification, banned devices, notification including repair, replacement or refund, records and reports, restricted devices, and good manufacturing practices. So basically what that means is you need a quality control system in place if you're going to market and sell and distribute this product. General standards have to be met, like the thing has to come sterile, and obviously because somebody's putting it in their mouth, if it has any bacteria on it, they could become sick. And it's not really good enough just saying, oh, we put it together in a clean environment, everything's all good. You need to follow sort of set guidelines and have your practice audited so you can prove that you're meeting these guidelines and standards. Yeah, so essentially what it means is that you would need probably at least like a handful of employees and quite a bit of capital, quite a bit of money behind your company to meet these standards. Generally on Kickstarter, you don't really have medical devices. And to be honest, I'm not even sure if Kickstarter allows medical devices to be marketed, just because the level of scrutinization and regulatory requirements is a lot higher than other markets. So if you're selling just sort of a general like lamp or light shade on Kickstarter, it doesn't have to arrive sterile. You don't really, the risks to the user are a lot lower. So yeah, I just sort of decided that starting like a small company with like a medical device, even though this isn't a super serious medical device, it would be hard work, and you'd probably end up moving away from the design engineering side of things and more onto the quality control and regulation of it. So it's not to say that this thing couldn't be a real product out there. But I think something like this, it would be a lot easier for an established company in the sort of medical device or hygiene field, like Oral-B or Colgate, for example, to develop this because they would already have the company infrastructure to meet the requirements to sell this. Trying to do crowdfunding with a small medical device, it would be, you know, hard work at the very least, and it wasn't really the path I wanted to go down. But regardless, I learned a lot from this project, a bit about business and even just sort of general Solidworks modeling. I'd never actually done any surface modeling, which I had to do to get all these sort of smooth ergonomic shapes. If you want to learn about surface modeling, feel free to check out some of my other videos on the channel. And if you do have any questions about this project, please comment below. I read all comments and generally reply if I have useful information to offer. And I probably won't share the files for this model just because this is more of an educational video as opposed to sharing designs or models. But thank you for watching. Please comment, like, and subscribe to the channel. If you have any ideas of videos you'd like to see me discuss in the future, please let me know. Thank you.